All right. It's a big week for us. What do we have tomorrow? You need to take your performance final, so you gotta come and see me. You weren't here for the performance final. What do we have tomorrow? Quiz. Wednesday we'll review the quiz. What do you have on Thursday? Test. I know some of you haven't got off to the best start, and I've had some people asking me about those retests. That'll be next week. Next week, first retest is on Wednesday. Second retest is on, because it's going to be broken up into 2 days. First is on Wednesday, second one's on Thursday, and then as long as it doesn't snow from now till then, Friday is off. There's no school Friday. Okay. Yeah, next week. Not this week. This week you have this thing starts ringing in my ear. Okay. What else was I gonna say? I lost my train of thought. All right, whatever. Let's just get started. I gave you this extra sheet. This page kind of shows up in your packet. I thought it was a little bit confusing to follow in the packet. Plus, it was a little bit smaller, so I just made my own sheet. Those of you that tend to subscribe to the belief of, hey, why am I learning this? Because when will I ever use this? Congratulations, your day has arrived. This is a momentous occasion for you, because you will probably go the rest of your life without ever using this or needing it. But for whatever reason, the powers that be who created the AKS decided that you needed to know how this formula for sum was derived. How did we come about it? And you're going to have to be able to demonstrate the fact that you know where it came from. So I've tried to make this as easy as possible for you. I have told you what's going to happen on each step. That's going down this way that tells you what to do. And I've also given you one side of the equal sign. And now it's just a matter of where you have to memorize it. So the first thing we start off with is a given statement. If you've taken geometry before, you should know what a given statement is. Something that we already accept to be true. And what we accept is that the sum of some finite amount of numbers is equal to the first number plus what's true about any what's true about the set of numbers in a geometric series. In order to be geometric, what has to be true about those numbers? They all have to abide, or they have to conform to a common ratio. So whatever that second number that you would be adding is the first number times the common ratio. And then when you get to the next number, what would happen? Well, you would multiply by the common ratio again, or squared. And then you would keep on going. That's what this dot, dot, dot means. You would keep on going all the way till the first number times the common ratio n minus 1. What does it mean by n minus 1? Well, let's pretend that there was 10 numbers, right? If you started with a sub 1, how many times will you have multiplied by the common ratio then? To give us something concrete. If there was 10 numbers, how many times will you have multiplied by the common ratio by the time you're done with it? 9 times. That's why you see n minus 1. Because whenever you're done, you've only multiplied by that common ratio 1 less than the amount of terms that there are. Follow me so far? Okay, this is just a given. This is just saying what makes a series geometric. Okay, so now let's follow the steps. We're about to prove. This is like a proof in geometry. We're about to prove that the formula works. What does the next step say to do? Multiply both sides by the common ratio. What's the common ratio? R. So if you notice here, we took the left side and we multiplied it by R. Just make it R times the sum. Now when we do this on the right side, this is going to be a little tricky to follow, but watch. We have that first A sub 1, and now we're going to multiply it by R, so that becomes A sub 1R. That's what this term became. What will the next term become? Plus A sub 1 R squared, and then plus A sub 1 r to the third, and then plus dot dot dot. And then eventually when we get to this last one here, because of that extra multiplying by r, we lose the n minus 1, and that just becomes a sub 1 r to the n. You don't need the minus 1 anymore, because you multiply by that extra r that wasn't there before. Do you follow me so far? Yes, no, maybe so? Say something if you don't understand what I've done. Okay, what does the next step say to do? Subtract. Specifically, if you look, they want us to subtract this minus that. Well, if you do that, well, look, this a sub 1 r cancels. This cancels. Even though you don't see an a sub 1 r to the third, that would be in this little dot 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 because we're leading up all the way to the end. This would cancel. Even this a sub r n minus 1, that would be within this dot dot dot. That would cancel out too. So the only thing that would survive this subtraction would be the first a sub 1 that was over here minus a sub 1 r to the n. If you understand it, great. If you don't, fine. Just memorize it because you're going to need it for the quiz and the test. Yes. Everything. The left side's already there for you, so just memorize that too. Any questions so far? Okay, we're trying to figure out how we came up with that formula for sum. What does the next step tell you to do? Yeah, factor the GCF. So if you look on this side, what do those two terms have in common? They both have S sub n. What do these two terms both have in common? A sub 1. So let's go ahead and do that. They've already factored out the S sub n for us on the left side. I took care of the left side for you. Why is it doing that? This thing is acting. So they've already factored out the S sub n. If we factor out the A sub 1, we get A sub 1 on the outside. That leaves us 1 minus r to the n. All I did was factor out a GCF. If I were to distribute, what would I end up with? Since factoring and distributing are opposites, what would I end up with if I distributed? What I started with. But again, I don't want to do that. I want to factor. Caleb, you with me? Having a good Monday? Having a good Monday? Good. And then finally now, they say solve for n. See, so what factoring has accomplished for us on the left side is that now we were able to pull the S sub n away from everything else. How would I isolate S sub n there? How would I get rid of the 1 minus r? If this means S sub n times 1 minus r, how would I get rid of the 1 minus r? Divide. So if I divide that out, now the S sub n is by itself. I have this a sub 1, 1 minus r to the n over 1 minus r. Does that seem familiar? That's the formula. That's the formula you had on that first page, even in my ugly handwriting. The formula that you were using all last week on the homework that you didn't do. The homework grades were probably the worst I've seen in quite some time. First period was worse. Second period wasn't as bad, but still pretty bad. Questions there? Cool. So let's get into some word problems. Okay. Make sure you memorize this page I gave you. Make sure you memorize it. So we're back on the notes packet now. An annuity is an account that is increased or decreased by equal deposits or payments that are made at regular intervals. The future value of an annuity is the total amount in the account at some time in the future. So you deposit $1,000 into a savings account at the end of each year for 10 years. That account earns 3% interest compounded annually. What is the future value of the annuity in 10 years? Let's focus on this first because you might remember that terminology, and if you're going to be studying for those retests, you're going to see it again. I believe last week within this packet there was a problem that involved money, and I was trying to demonstrate to you how that common ratio had a 1 in front of it. If something is, see, in order to make it geometric, it has to increase by a percent. So like, you're going up by 5%, or in this case, you're going up 3%. But some of you were maybe were confused by where that 1 came from. Well, let's go back to the formula for compounded interest, right? We had an original amount, which is in this case is like 1,000, and then we would be 1 plus that that rate of increase, the growth rate, to the power of how many years, right? And when you add 1 plus 0.03, that gives us 1.03. So all I'm really trying to show you here is what is that 1.03 going to represent? This is not the formula I'm going to use here. What this would work for is if I wanted to know how much I put in on that 10th year. That would tell me what that last payment would be. But I want to know how much I'm going to have in total. What's the total value going to be? But can somebody tell me what? There's a big circle around it. What's the common ratio going to be? How much is it going up each year? 1.03. So now let's go to our sum formula. And I'm showing you this because look, it's saying that it says I'm only going up 3%, but make sure that you make my common ratio 1.03%. What was the first amount? And last thing I need is number of terms. How many terms am I going to have here? 10, yeah, because I'm saving for 10 years. So the sum of these 10 deposits is going to be the original amount, which is 1,000, times 1 minus 1.03 to the power of 10 over 1 minus 1.03. If this were a free response problem, the majority of your points are going to come from this. Did you substitute the correct numbers into the correct spots? After this, the only thing you're going to be assessed on is did you come up with the right amount. So if you want to put this whole thing into the calculator, fine. But you got to show us where you where you substituted and what you substituted. I did this one last period, and I think it gave me like a long number. When I tried to, like, I went ahead and did that, and I tried dividing it by 1,000, but it gave me a big number. So see if you can fit that whole thing in the calculator and tell me what you get. You definitely should not get a negative because you're putting you're putting money into an account. Let's see. Do we trust Jenny? Can Jenny be trusted here? Let's check your math. 1 minus. Okay, good. You hit equals. Excellent. Oh wow, because you went up and you selected and you divided by answer. Good. Oh, you messed it up for everybody, Jenny. Almost. It was times 1,000, not 100. Oh wait, did you go? Oh, you went back and did it again. You bet we went back and fixed it. I take it back. I'm sorry. You did catch your own mistake. Good. So we're getting 11,463 with 88 cents. Is that what everybody got? Juan, what would you do with $11,463.88? You wouldn't go eat a pizza from the Mellow Mushroom? Because those are pretty expensive. Might cost that much. You could buy a Chick-fil-A, like a franchise. I don't know. Supposedly it's one of the cheapest ones to buy, but then they kill you because they own it all. Like it's not, they take most of the profit. What's up? You keep getting a negative? It's Yasha's fault. Let's see. You're trying to do too much in the calculator probably at once. I would just try using your, take advantage of the equal button. So let's start off in the parentheses. 1 minus 1.03 power 10. And just hit equals. Okay? Then you're going to divide that. You could either, if you know that 1 minus 1.03 is negative 0.03, you can put that in. If not, 1 minus 1.03. But make sure you put that in parentheses. I think that probably was your issue. You probably weren't putting that in parentheses. Okay, now that gives me a positive already, times 1,000. There's your number. Any questions? Yash, did you figure out why you were getting a negative? Sophie helped you? Thank you, Sophie. Thank you. Nina, the board's this way. No questions on that one? All right, number 2, 2 online movie sites are competing for new customers. Information about how much customer would pay each company is outlined below. Company 1 offers a 4-year plan that charges $15 for the first month. After the first month, the rate increases by 1% each month. Company 2 offers a 4-year plan that charges you $175 for the first year. And then after the first year, the rates increase by 20%. The services provided by each company are the same. So let's write an equation that represents the monthly amount A in dollars that a customer would pay after M months for company 1. And then say what type of a function is represented there. All right. Well, anytime that you're going up by a percent, what type of a function is that going to be when you're increasing by a percent? Somebody mumbled it. Exponential, yeah. It's going to be an exponential function. Now, this is not a sum. We're not using the sum here. We're just showing a formula that says where I could plug in and say, hey, how much am I going to be paying in the 12th month? How much am I going to be paying in the 5th month? So this is we have not reached the sum formula yet. But we know this from before. The initial amount, we've done exponentials before. The initial amount for the first company is $15. Okay, then it's 1 plus. Now the thing is, even though that this is going up each month, we're not compounding it because the formula is going to be based on what does it say? It's going to be based on months. So we don't have to do the whole divided by 12 and then times 12 thing. What percent is it going up? So it'll be 1.01 to the power of months. This won't tell you a total, but this will tell you, like if I want, hey, how much am I going to pay in the 20th month? You can plug that in for M. Write an equation that represents T, which is the total amount in dollars that a customer would have paid after M months using company 1. All right, so now they're saying total. So now we're going to use the sum formula. What's the first amount? 15. 1 minus, what was the common ratio? 1.01 to the power of months over 1 minus 1.01. That would tell you how much you've spent in total. If I plug in like a 20, that'll tell me how much I've paid in total after like 20 months. If I plug that same 20 into here, that'll just tell me what I'm paying on that 20th month. Write an equation that represents the total amount in dollars. So this is a total. We're going to do a sum here again. But now they're going to call this S. That you would have paid Y years after Y years using company 2. So the sum is going to, so here's company 2, but now we're skipping straight to total. We're not going to do the exponential. Just like the formula to figure out what you'd pay in each year, there's already going to be the total. What's the first amount for company 2? 175. Then 1 minus, what's the common ratio? 1.2. Good, because it was going up 20%. So 1.2 to the power of Y years over 1 minus 1.2. And then finally, this is the big payoff here in part D. This is the moment we've all been waiting for, where we figure out which is the better company to go with. So let's do company 1, which we said the total, and it depends on months. Now they want to. These were both 4-year plans. You had to sign a 4-year commitment. But the first company was based on months. How many months are there in 4 years? 48. So the total over 48 would be the $15 initial month, and then we're going up. It said one. Is it 1% every month? So 1 minus 1.01 to the power of 48 over 1 minus 1.01. If you want to use the calculator, you can. This one's a little bit easier to simplify, because I could do 15 and then 1 minus 1.01 to the 48 over, this becomes negative 0.01. And when I divide 15 divided by negative 1.01, you don't have to do this again. That gives me negative 1500. So that's negative 1500 and then 1 minus 1.01 to the 48. It just makes it a little bit easier to tap into the calculator. Yes, Julian. Because it's 1 minus 1.01. Anytime you subtract a bigger number, you get a negative. The key is that the numerator is going to also give you a negative, and what's negative times negative? Yeah, that's the key there. If your common ratio is greater than 1. If your common ratio, if you're increasing, it's going to end up being negative. Somebody with a calculator, go. Come on, quick. The quicker you answer, the quicker we finish. So we spent $918.34 with company A. Let's say this is Netflix. Netflix cost us that much. But now let's go check Hulu. Hulu, we called it S, and it was based on years. So I could just put S at 4 years, was equal to, what was my first payment there for the first year? 175, but then it was 1 minus 1.2 power of 4 over 1 minus 1.2. Julian, notice how you're going to get a negative again on the bottom. These steps in the middle you don't have to do, but if you want to have to put less stuff into the calculator, I know that 1 minus 1.2 is negative 0.2. And when I multiply that times 175, sheesh. 4 times 4 is 350. 350 is 700. 875, negative 875. No? Did I get it right or wrong? Negative 875? You got a 56? I'm just asking you for this right here. I haven't done everything else. I'm just asking you for that. What is 175 divided by negative 0.2? Negative 875. I'm always proud. Except when you don't do your homework. And then now you can put that into the calculator. It's a little bit less stuff to type. Jenny, you got that one too? What you get? $939.40. So when you buy something, do you prefer to pay more money or less money? Less. So they asked you, which was the better company. What company would you rather go with? Company one. Do they call it company A or company one? Yosh, you're tripping, man. Company one. And then they also want to know how much would you save. So how would you calculate how much you saved? And that gives you $21.06. Maybe not enough to buy a Chick-fil-A, but enough to get like a chicken sandwich. We'll make it a spicy chicken sandwich so that you can stay awake. Juan. You like spicy chicken sandwich, Zeke? It's good. Have you tried the one that was like the big craze over the fall? Which one? Popeyes, yeah, that one. That was always sold out. You tried that? I haven't tried that yet. It's good. Which one do you like better, Popeyes or Chick-fil-A? You're a Popeye guy, huh? Gotta go try that. Questions? All right, let's do this then. Let's jump to this because I want to make sure I have these here. I want to make sure I get these done. This is on the homework. You didn't get it? Cool. So now we're gonna get it. What do we need in order to find the sum of a finite series? Of a finite geometric series? You need the initial amount. Do we have that? We need the common ratio. We don't have that, but it's not that hard to find. 2. Uh-oh. What's going to be the tricky part here? How do I find number of terms? Well, Papa Romero hooked you up with that. I gave you a formula that said use log of base R. What's my R here? What's my common ratio? And then just do last amount divided by first amount plus 1 in the notes. It may not. Learn it anyways. I've given you enough hints for you to probably deduce what's going to happen on the quiz, but yeah, I know. And being that I believe when I introduced it, I said I don't think any other teacher's giving this out. I'm the only one, so do you think it would probably show up on a test or quiz? Yeah, maybe not, but look at that. Yash said it showed up on the homework and he couldn't figure it out. But now you can. How many numbers are we gonna have here? Did we forget how to evaluate logs? Thank you. N is 11. So we have number of terms, we have common ratio, we have first amount. Even if you didn't know that formula, right? But let's say hey, there was $1 million prize for finishing the homework or whatever. Like you really needed to figure out how many terms there were there. What else could you have done? Yeah, just keep on multiplying by 2 until you figure, 3 times 2 is 6, and 12. And then eventually what would have happened, 24 times 2 is 48, then 96. And eventually you would have reached this number, and then you could say how many terms there are there. But this is a shorter way of doing that. So the sum of these 11 numbers is the first one, which is 3. 1 minus the common ratio, which is 2 to the 11th over 1 minus 2. I'll use my super awesome math skills. I know 1 minus 2 is -1, and 3 divided by -1 is -3. So if you want to minimize what you're putting into the calculator, you can just do that. You get the same thing. -3 times 1 minus 2 to the 11th. Okay. The quicker you answer, the quicker we can move on. Use digits. 6141. Anybody disagree with that? Miles, you got the same thing? Good. Don't look on Sophie's paper. She doesn't like that. Okay, let's try this one. What do we call this? Summation notation. Good. So we still want to add a group of numbers. They're just writing the numbers a different way. We still need the same things, which are first amount, common ratio, number of terms. Actually, I can put these closer together. How do we find first amount when we're in summation notation? Plug in the lower limit. If I plug in this lower limit in for n, what is 1 minus 1? And what's anything to the 0 power? Because 1 minus 1 is 0. If I plug in a 1 for n, 1 minus 1 is 0. So what's 2/3 to the 0 power? Put it in the calculator. Go, 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 go. 2/3 to the 0 power. Do it. Do it. Story checks out. It's 1. All right, so what's my common ratio here? How do you know it's 2/3? Because Stone Cold said so. How do you know it's the... No, it's not because of the parentheses. It starts with B and ends with ace. It's the base. Yeah, that's the base. In summation notation, you look at the base. And then finally, the one that I'm warning you right now, I'm calling my shot like Babe Ruth over here, and I'm going to tell you what's going to happen, and it's going to happen anyways. And that's that you're going to botch something on the test and the quiz because you weren't listening. It's going to happen. It always, no matter how much I warn you, it's going to happen. Because when I ask for number of terms, everybody starts looking here. But that's only n when this is 1. Because really, what's the only formula that always works? What's the formula I showed you for summation notation? Upper minus lower plus 1. 4 minus 1 plus 1. And yes, it is true that in this case it does give me 4. But then on a test or a quiz, we'll throw one out you where the bottom one is not 1. And then, caca. Yes, sir. As long as you do upper minus lower plus 1, you'll be fine. What we're trying to avoid people getting is in the habit of just only looking at this number. Because, yeah, when the bottom number is 1, it's just going to be that number. But it's not upper minus lower plus 1. What is 4 minus 1, but then always plus 1 at the end? What's 4 minus 1 plus 1? 4, yeah. So the sum of these 4 numbers is equal to, what's the first amount? Yeah, we said the first amount was going to be 1. So you don't even really need to write it, to be honest, because 1 times anything is itself. So we'll write 1 minus the common ratio, which is 2/3, to the power of 4 over 1 minus 2/3. It's a lot of fractions, huh? So the next thing I want to do, I'm going to get that fraction bar there, the big fraction bar, and I'm going to turn it into a regular division. I'm allowed to do that as long as I get my numerator and denominator and just put them in parentheses. In the numerator, I can go ahead and take 2/3 to the 4th power. It's not that hard. Just take each number to the, you can distribute the exponent. What's 2 to the 4th? 16. What's 3 to the 4th? 12? Oh dear. It's 81. Don't worry, Zeke. I won't tell anybody that it was you that said it. How about in the denominator? If you want to get fancy and do least common denominator, you can. But do we know what 1 minus 2/3 is? If I have a whole pizza and I take away 2/3 of it, do you know how much will be left over? Yeah, 1/3. Now on the numerator side, I will use LCD, but in order to make those denominators match, what would be the best way to write 1 as a fraction? Very good, 81 over 81. Take that, Caroline. And 81 minus 16 is 65 over 81 divided by 1/3. All right, so we're making some progress. Finally, at the end, this was funny. I asked last period, I asked them, how do we divide fractions? And they said just put them in the calculator, which sadly is true nowadays. But yeah, multiply by the reciprocal. Flip the 1/3. So this becomes a 1, this becomes a 27. So without having to round, because the issue with the calculator is unless your calculator has math print, your calculator is going to give you a real nasty decimal here. But I was able to do it and keep it exact without rounding. Hey, Sid. What jersey is that, Alexi? Juventus. You like Ronaldo? A little bit. Hannah likes Ronaldo. No questions? All right, so let's go back then to word problems, your favorite. And let's actually do, let's skip to this one. Let's go to 15. Ali deposits $2,000 into account at the end of the first year, at the end of each year for 4 years. The account earns 5% interest compounded annually. Complete the table to show the value of each deposit as well as the total value of the account at the end of the 4th year. See, like I don't like the use of the word deposit here because it's telling you that he's depositing 2,000 into the account. So like they use the word deposit. Well, the deposit should just be 2,000, 2,000, 2,000, 2,000. But I don't believe that that's what the problem intended. Okay. So what we're gonna do is say, hey, the first deposit was 2,000, and then we're gonna. What would be the common ratio here if it's earning 5% each year? 1.05. So the whole purpose of this problem is to show you that the formula works. It's another thing to kind of prove the formula works. So let's just get that 2,000 and multiply it by 1.05 and tell me what you get. Two one. Okay. And then times 1.05 again. 2205, and then times 1.05 one more time. 2315.25. And add all those numbers up. Eight, 6, 1. Yes, is that correct? 2? Ah, I forgot to carry the 1. It's all your fault, Landon. 8, 6, what now? 20.25? Fine. So now here, part B just says, hey, use the formula basically to show that we end up with the same thing. So the sum after 4 years is going to be, what was the first amount? 2,000. This is the formula we started the day proving. 1 minus common ratio is 1.05 to the power of 4 over 1 minus 0.05. You can put the whole thing in the calculator if you want. You can break it up into pieces. If you were to break it up into pieces, this would come out to negative 4,000 times 1 minus 1.05 to the fourth. That would be if you were to simplify this part of it over there. What do you get? What do you get? What do you get? Yeah, no! This is where you're supposed to have your aha moment. And come on. And see, wow, look, it ends up giving me the same thing. Remember that the quiz and the test are also going to have piecewise. I know you haven't seen it like in a week, but you don't. Piecewise and geometric, that's it. All right, let's skip. I like this one down here, Mrs. Turner. The one, number 17. Can you read that? No, it's hard to read on yours. Miss Turner wants to accumulate $50,000 for her daughter's future college costs in 12 years. How much does she need to deposit into an account at the end of each year if the account earns 4% interest compounded annually? Okay, so this is a pretty good question. So she has an account that gives her 4% interest, but by the time she's done, she needs $50,000. So that's going to be the final amount. What she wants to know is how much how much does she need to start with? She would have to continue depositing that amount at the end of every year, but how much would she need to start with? So let's just call this A sub 1, I guess. Times 1 minus, what's the common ratio? 1.04. How much is she time is she giving herself? 12 years over 1 minus 0.04. Okay, now this one you can't just use the calculator. There's more. Oh, I'm gonna run out of space. I wrote it too big. So on the bottom, this gives me negative 0.04. Juan got the same thing. So then I need to isolate the variable. Times negative 0.04 times negative 0.04. Ooh. So that cancels out down here. Where can I continue this? I'm just going to continue it here. Is this negative 125,000? Somebody with a calculator put... Actually, no, I'm multiplying. No, it's going to be less than. Oops. What is it again? Negative 200 is equal to A sub 1. 1 minus 1.04 to the power of 12. What would I have to do next? Son of a gun, you're right. I miswrote it. She wanted 50,000. So that should just add a 0 there then. So it's negative 2,000. Thanks, Hannah. Jenny, do you agree? Can we continue? So what's the last step to get this first amount by itself besides putting the book away? Kendall's getting jealous. And when Kendall gets jealous, she gets even. So you should put the book away. You guys need to be friends. Last step. Let's get A sub 1 by itself. Divide. Divide by 1 minus 1.04. You can try to simplify that first, but that's going to be a huge decimal. So 1 minus 1.04 to the 12th. 1 minus 1.04 to the 12th. So put that into your calculator. Put negative 2,000 divided by 1 minus 1.04 to the 12th. And that will tell you what she needs to start off depositing every year and then continue depositing each year. No, you need to use parentheses, girl. So this would be negative 2,000 divided by parentheses 1 minus 1.04 power 12. Because that tells your calculator to do the division at the end. 33,000. Sorry, 3,327 and 61 cents. That's how much she has to start with. If you didn't get that with your calculator, tell me now. I'll help you put in the calculator. I know it's a lot. All right, so then let's end the day with this. Let's go up to the top. I want you to do both of those two on your own, 12 and 13. I'll give you like a 1 minute head start while I go reach for my calculator, and then I'll come in behind you and do it. Where's my calculator? You got a quiz tomorrow. You should be able to do these on your own. Luckily on these, they gave you the number of terms. So, but like Yash, you see how they're giving you the first and the last, but they are giving you the number of terms, so you don't have to use that log formula. That's kind of what Jonathan just asked. And yes and no. Just learn it anyways. Some might not. What would I do wrong here? 1 minus 0.5 power 6 equals times 10. Okay. Check your work. Check my board. See if you got something different. If you did, say something now. Yes. The reason I use decimal is just because they were using. I tend to kind of stay with what I'm given. So since they gave me so many decimals, I just went with decimals. It shouldn't make a difference. The only thing to be careful with is the rounding aspect of it. Make sure that you don't round unless you're told to round. Normally, if given the choice, I'll go fraction over decimal. But since this one already started, with decimal. Yeah. Any questions? All right. Quiz tomorrow. Say that again.